All right, guys. So this is the last section of chapter 11. Finally made it. So it's section 1111, make a wish. All right. So this one is the effect of changing dimensions. Okay. And so basically, like, think back to scale factor. So if the dimensions of a solid are multiplied by a scale factor of a, so for this one, we're going to use this variable a. So that's a scale factor, okay? So basically, like, we have this small, let's say we have this small little building, okay, right there. And then we have big building over here, okay? What we're looking at is what number do we multiply the dimensions by to go from small to big, okay? Or big to small, doesn't matter. They're going to tell you if they're going from big to small. They're going to basically tell you in a way what the scale factor is. They might say the scale factor is double. They might say it's multiplied by 5. They might say it's 1/4, whatever. But basically, after they tell you what the scale factor is, we're going to try and find, the surface area is how many times the original surface area. So, like, if this surface area is 2, how many times larger is the big surface area? Okay, it's not just going to be multiplied by the scale factor. Okay, it's going to be a little bit different. So surface area is always in square units. So that surface area is going to be a squared times the original surface area. So a squared times larger, or a squared times less than, but whatever it may be, it's going to be a squared. Okay, so it's going to be that scale factor squared. The volume is always in cube units, so it's going to be that scale factor cubed. So again, like, if the small volume is 2 centimeters cubed, then all we got to do is we got to cube that 2 to see how many times greater the other volume is. Okay, so it's kind of, I think once we get into it, it's not too bad. Okay, so if you're a little bit confused, that's okay. All right, that's okay. Let's just do some examples together and you guys will see how this works out. So surface area. So surface area, we know, is going to be that scale factor squared. Okay, so the first one tells us that if the dimensions of the figure are doubled, so we have this cube again, okay? Then we go to this other cube. Boom. And basically, we are doubling those dimensions. So the scale factor, that a, if we double something, all right, if this one's 5, then this one would be 10, okay? So that's how we double things. So if, the one side over here is 5, the other side over here is 10. All right, so that's what we're saying, okay? That's what we're saying there. So we know doubling means 2, so our A here is 2. That's the important thing. You got to figure out what that scale factor is. You got to figure out what that is first, okay? Now, we're doing a surface area example, and it says, how many times larger will the surface area be? Okay, so again, surface area is going to be that scale factor squared. So when we're doing it, we found out that our original scale factor was 2 because we're doubling it. We're going from like a 5 to a 10. We're doubling the dimensions. So how many times larger will the surface area be? Well, we take that scale factor, that A, which is 2, and we square it. So how many times larger will the surface area be? 2 squared is 4, so it's going to be 4 times larger. So hopefully that makes sense here. This video is going to run out of time, but just to recap what we just did, this was a surface area example. So we find that scale factor, that A, so it tells us that the dimensions of the figure were doubled, so we're multiplying it by 2, so the scale factor here is 2. And all we do is we take that A, that scale factor, and we square it, since we're talking about surface area,